Hi there, Valerie and Kyle here on EchoSlam. Okay, picture this. Just a colossal fireball screaming towards a planet. It's coming in so fast, collision feels totally unavoidable, and then bam, the impact leaves this enormous crater, right? And instantly, thousands of cubic miles of rock just vaporize, kicks off all these terrible natural disasters. Now I know what you're probably thinking, Earth, right? 66 million years ago, that huge collision, the one that wiped out the dinosaurs, 3/4 of other life. Well, here's a bit of a twist for you. The disaster we're actually talking about, it happened on a completely different planet. We're diving into Mars, way back around 3.4 billion years ago.
Yeah, it's really fascinating. Scientists, they now think our neighbor Mars actually went through something, eerily similar to our own Chicxulub impact, and that really raises a big question, doesn't it? Could an asteroid hit have caused a mega tsunami on Mars? On the red planet, a place we usually think of as, dry and dead.
So today, that's our mission. We're taking a deep dive into these cosmic collisions. We'll go from those ancient oceans on Mars, look at Earth's own close calls, and maybe touch on what science is doing about it now.
Okay, so let's unpack this Mars thing first. You're saying scientists have found a specific crater. They have. It's been nicknamed Paul by the researchers. It's about 68 miles across. Sits in this region that's nearly 400 feet below what they think was Mars's ancient sea level.
Right. So Paul Crater, how big an impact are we actually talking about to make something like that?
Well, the simulations, they suggest Paul could have been formed by maybe a 5-mile wide asteroid. Think about that. It's like Mount Everest just vaporized in an instant.
Wow.
The energy from that, it would have created mega tsunamis maybe 900 miles away from where it hit. And what's really interesting, maybe even more so, is the idea that Mars might have had 2 mega tsunamis millions of years apart.
Ew. How does that work?
Well, the first in, liquid water, but the second one, possibly in these rounded chunks of ice, suggesting the planet was cooling down.
Huh. That dual event idea, that really tells us a lot about how Mars's climate changed over time, doesn't it?
Exactly. A really dynamic history of water, which, totally impacts our search for whether life ever existed there.
And then, okay, let's bring it back to Earth. How does this Paul crater compare to our Chicxulub impactor, the dinosaur killer?
Well, the Chicxulub asteroid, that was bigger, probably at least 6 miles across. And it slammed into relatively shallow seawater near the Yucatan Peninsula.
And the effects were global, basically.
Absolutely.
Yeah.
Left its mark everywhere. Researchers found these mega ripples carved into the Earth's crust way up in central Louisiana.
Mega ripples from the tsunami wave.
Seems like it. And newer studies are suggesting that tsunami was so powerful it actually eroded sediments on the seafloor half a world away. The models show Chicxulub produced waves, get this, up to 30,000 times bigger than the 2004 Indian Ocean tsunami.
30,000 times? That's almost impossible to picture.
Imagine a wave almost a mile high. That's like stacking 2 Burj Khalifas, just enormous.
Makes you kind of glad we weren't around for that splashdown. But, these impacts weren't just about the dinosaurs, were they? There's talk of even older, bigger ones.
Oh, yes. There's evidence, particularly from northwestern Australia, suggesting maybe an even more catastrophic collision happened way earlier, like 3.5 billion years ago. We're talking maybe an asteroid 12, maybe even 18 miles across.
That's huge. The energy release must have been
thousands of times more powerful than all nuclear weapons on Earth combined. We're still figuring out exactly what it did to early Earth, the conditions for early life. But finding it definitely reshapes how we see our planet's really violent beginnings.
So it makes you think, doesn't it? We've got, over 30,000 objects tracked near Earth now, and maybe 1,500 are considered potentially hazardous. Are we just waiting?
Well, that's the critical question today. But luckily, unlike back then, we're not just sitting ducks, we're much more prepared. Scientists are constantly watching the skies.
Right, like that asteroid Apophis, the one discovered back in 2001.
Exactly, Apophis is about 1,200 feet across.
And it's going to make a really close pass in 2029, isn't it? April 13th, something like 19,000 miles away.
That's the one. It'll actually streak across the sky, visible to the naked eye in some places. But the key thing is, we know about it well in advance.
Which gives us time.
Plenty of time. We're not just observers anymore. We've actually developed technologies, several ways really, to prevent a real-life disaster movie scenario. Things like spacecraft nudges, literally just pushing an asteroid slightly off course over time, or gravity tractors.
Gravity tractors?
You basically park a spacecraft nearby, and its own tiny gravitational pull over a long period can gently tug the asteroid onto a different, safer path. The point is, we have options now and constant monitoring.
So looking back, we've covered billions of years here. We've seen how these giant impacts really shaped both Mars and Earth. From those huge waves from the Paul crater on Mars
To Earth's own almost mile-high tsunamis from Chicxulub, and maybe even bigger ones before that.
It's definitely a powerful reminder, isn't it, of just how dynamic the universe is, but also how much we've actually learned, how proactive science has become.
That's the key takeaway, I think. We're no longer helpless. Understanding these past events on Mars, on Earth, is directly helping us figure out how to face potential future threats.
So, what does this all mean for you listening? Well, maybe the real aha moment here isn't about digging bunkers or building ocean shelters, Perhaps it's realizing that these incredible stories from our planetary past, these histories we actually share with worlds like Mars, they aren't just ancient history. They're actively guiding our future now, making us smarter, more prepared than ever to, steer clear of our own cosmic collisions.